In this lesson, we're going to give best practice tip in React. We're going to talk about S.O.L.I.D, specifically the single responsibility principle and how that principle can be applied to React components. As usual, this entire lesson is available at theacademies.com site. You'll find a guide and a step-by-step for everything we talk about in this lesson, including the source code. So here's the plan for this lesson. We'll start by discussing what S.O.L.I.D is. Then we'll focus on one of the principles in S.O.L.I.D, the S in S.O.L.I.D, the single responsibility principle. In my opinion, it's the most important principle in regard to React components. Knowing this principle and knowing when you break it really helped me organize my React component and organize my code better. So we'll give example of it's better to learn this principle in React components by showing a bad example. So we'll give a bad example and then tips of how you can spot those bad examples, how to spot when you're breaking that single responsibility principle. Then we're going to focus on a good example. We're going to transform the bad example to a good one, and you'll see how it structures your code better. It's easier to test your code, it's easier to share your code, and in general your code will be much more organized and clean. Let's talk about S.O.L.I.D. S.O.L.I.D is an acronym for a group of 5 good development principles. Those principles were originated to talk about object-oriented programming. They were not originated for React components, for user interface components. It's important to understand it, but it's also important to understand S.O.L.I.D and how it relates to our user interface components. So I see S.O.L.I.D more as a guideline, as an inspiration, more than an absolute thing that I have to pursue all the time. It's more like giving me a guideline of how to organize, arrange my code, giving me ideas for design pattern. So it is important to understand what S.O.L.I.D is, understand how it relates to your React component, and it will really help you organize your code better. So the S in S.O.L.I.D is the single responsibility principle. And basically, if we look at this principle and throw it to React component, it means that your React component needs to solve a single task, a single problem. So if your component is your React component is really big and it's solving a lot of different issues or problem, you're probably breaking this rule. So there are different ways, different tools that you can maintain that single responsibility. Maybe extract some logic to custom hooks, maybe split your big components to smaller components, maybe extract the error logic to error boundary, extract the loading sign to suspense. There are different tools that React gives you to actually maintain that single responsibility principle for React component. The open-close principle means that when you create a component, it can be open for extending that component, but closed for modification. And I like to see a good inspiration for this is a popular library called React Select. React Select is a library that you can use to create a form select. And in here you have select, but they actually used you can use the components prop or the children prop of a component to actually override every single element in the select. So in here you can go to components and you have a list of components that you can actually substitute in the original React Select. This makes the React Select very open to change. So you can actually update this React Select and actually replace components so it will perfectly fit your use case. And I often use this library, and I created really different and amazing form selects in different applications based on the fact that they allow to extend their code by replacing components. Now, this is usually done in React by either doing it through the children prop or either doing it through component props. So this is the open-close principle. List substitution principle state that you can, let's say you have, for example, a table, and you find yourself need to replace that table with another table. And then after 6 months, you need to replace that table with another table. So maybe it will help to actually create some kind of contract for what your table calls need to look like. For example, creating an interface for your props, and then you can easily replace that with different table if you need to change that table. So this is the substitution, which is defined by basically a subclass, but in our case we can define it with props interface, for example. So interface segregation basically means that your component, your React components, is getting in the props what it needs to get in the props. It's not getting items that is not using. For example, so if you're sending a lot of props that you're not using, if you're, for example, can actually obtain the props yourself by calling a hook. So you might also use this instead of passing the props. And dependency inversion means that you depend abstractly on items. For example, you don't depend on Axios for doing your calls. You depend on something abstract like an interface or class to make your call. So this is easily replaceable, and you're not depending on a third package or a third component. Rather, you depend on abstraction of something. So these are the S.O.L.I.D principles. I think that for me, the most important principles that I keep in mind are the single responsibility is the most important, I think, for me. It really helps me organize my code. The open-close principle, I do apply it when I have a component that I know that I'm going to extend, so I do think about it also a lot. The substitution, I usually think about only when I'm doing refactoring and I see that I often need to replace something, so I think about that for refactoring. The interface segregation, it is something that I look about the call for the component, the props that I'm passing. I always examine it to see that I actually the API calls are the function, the components are actually getting the props that they should. Regarding the last one is, in my opinion, is the least important for me in some cases. Only when I do refactoring and see that depending on some package is a problem, only then I focus on it. But in general, the S.O.L.I.D principle of more for me like an inspiration, a guideline how to think about my code. It's not I have to obsessively go over those rules. It's more like a guideline and inspiration. Now that we know what S.O.L.I.D is, let's focus on the single responsibility principle, the S in S.O.L.I.D, and how it affects our React components, because this principle really helps you organize your React component in a better way. So the principles state that every component should solve a single specific problem, a single task. And although it sounds trivial, when I check PRs, this is a very common mistake that many React developers are doing. And I think the most important thing to focus on is how do I spot when I make this mistake. There are certain tips that will give you in this lesson that you will know when you're breaking this principle. And it's very often for React developer to make this mistake and break this principle. So we'll focus on this lesson in how we improve this skill. How do we organize our React components better so each component will solve a single problem. So it's really important to understand when you are breaking this rule, and we'll give example and best practice tips how to know that you're breaking this rule, and we'll give you also tools to help you keep and maintain that you have a single responsibility in your component. So to demonstrate the single responsibility principle on React components, we'll create a new React project, and we'll create a bad example of creating a React component that is not following the single responsibility rule. And what we're going to create is a to-do list component. So let's open the terminal and start a new React application. So you'll use create React app, and we'll call this application single responsibility demo. And after our project is created, we'll open this project with our IDE. So we created a new project and opened our project with VS Code. Now let's create a bad example where we break the single responsibility principle. So in the source folder, I'll create a new component, a new file called bad to do. And what this file is going to do is we are going to export a component called bad to do. And the component will do the following. It will send a query to a server. Now to send a query to a server, we are going to use React Query. So let's install React Query. So I'll open React Query documentation and I'll install React Query. Now after you install React Query, you need to wrap your components with the React Query context. So let's see if we have a quick start. So you need to create a query client and wrap it with the query client provider. So let's do that. So let's go to our index.js and let's import from React Query. Let's import the query client provider, query client provider, and query client. Let's create a new query client. And let's wrap our application with the query client provider. Great. Now we can use React query to send our query to the server. So let's go back to the bad to do, and we can import from React query the use query to send a request. So we'll send a query to a server to grab to-do list. So I'll use the use query, which has a query key. Query key. Let's name the query key to-dos. And they have also a query function, which basically will use the fetch to, let's see this, we'll use the fetch from, let's fetch it from a public REST API to grab to-dos. So let's fetch from here. Maybe it's the same address, I'm not sure. Okay, so let's fetch, grab the response, then grab the JSON from the response, and then return the data. Now the use query returns data. It can return is pending while the request is being sent, and it can return an error object. So this is the sending of the query. Now one thing that our component is going to do is, while the request is being sent, we will display a loading sign. So if pending, I'm going to return loading. The component will also take care of an error. So if the request is failing, I'm going to display an error message. So if there's an error, we'll display an error message. So if error, return div error message. Great. Now our component is going to, if there is no error, now our component is going to grab the data, grab the to-do items, which looks like this, has ID and title, and iterate on those ID and titles and display a list. To display a list, we're going to use MUI. To display a list, we're going to MUI, we're going to install it, and we'll use the components list. So let's get back to our component and render the to-do list. Now to do this, we're going to install MUI. So I'm going to open the MUI documentation and install MUI. And I'm going to use the components. Let's see, they have here a list component. So we're going to use the list component here. So let's display the list, render the to-do list with MUI components. And I will import from MUI material. They have a list, and they have a list item, and I think they have a list icon, list item, and I don't remember what other list element, but let's let the Copilot finish our complete everything. So I can actually see the documentation here. So let's show our code. They have a list item button, a list item icon, a list item text. Let's import all of this. List item text, list item icon. And let's return here. Okay, so a list, let's complete this with the data. Now the data will start with undefined until the request is finished. So let's place a question mark here, and I'm mapping the to-do, and I'm going to list item with a to-do and list item icon. Okay, if to-do completed, let's say list item icon is just the X. I don't think we have a completed there. Do we have completed? Oh, we do have completed. So let's keep this logic. If the completed, so we'll check. Otherwise, there is an X, and we're going to place an item with a text. So let's place our component. So I'll go to the app.js, and I'm going to import our component. And I'm going to place it instead of everything else. Okay, I'm going to delete this. Let's see if our app is working. Okay, so great. Our app is displaying list items. So it is working. It's grabbing it from a server. So let's take a look at what our component is doing. This is a bad example of to-do. Although it is working, we see that our to-do is doing a few things. We can kind of sense that it's breaking the single responsibility principle. The component is sending a request. It's displaying a loading sign. It might display an error message, and it might display a list. So this is an example of a component that is breaking the single responsibility principle, and we'll go over different aspects of this component and try to understand from this component tips how do you know when you're breaking this principle and how to maintain this principle. So we'll take this as an example, as an inspiration, a bad example to know how to do things right, how to keep the single responsibility principle. So let's start with best practice tips, how we can avoid the breach of the single responsibility principle. And to follow along those tips, we are going to create a good to do component. So I'm going to create a folder called good to do. And in this folder, I'm going to create the component good to do.js. And we are going to create here a good to do component. And now we are going to follow best practice tips, how we can keep this component working with single responsibility principle. And the first tip I have for you is writing comments. Writing comments before you start working on the component. Document your components before. The comments help you organize and plan your work. So if we would write comments on the good to do component, you know what, let's go to the bad to do and write comments here on the bad to do. So if we write comments on the bad to do before we actually wrote it, right before, because it helps you plan. So before we actually wrote the bad to do, we could have written what we're going to do in this component. This component will do the following. And we would write, it will send a query to fetch the to-do list from a server. And while we write the comments, while the request is being sent, it will display a loading message. If there are error, will display an error message. If the request is successful, we'll display the to-do list. While we are writing the comments on this component, we can notice that during the planning phase, we notice that this component is doing a lot more than a single responsibility. So let's go to the good to do. Before we even start writing the component, let's document and plan what this component is going to do. So instead of doing all of this, what the good to do will do is render the list of to-do items. And that's it. That's the single thing that this component will do. And when you write the comment, you'll notice that this component, the good to do, is actually keeping with the single responsibility principle, while the bad to do is actually not doing that and doing a lot of things that it should focus only on one thing and not this entire list of things. Okay, tip number 2. Check your imports. If your imports are really all over the place, are not on a certain topic, but are really spread between different topics of your app, it's a good sign that you're breaking the single responsibility rule. So in our case, we need to go to the bad to do and we need to inspect the imports. It's not always a sign. In this case, it's not that clear that our imports are bad, but if you have a long list of imports in your component and those imports are really on different topics of your app, for example, you're importing from the models really different data types, or you're importing stuff that handle forms and other stuff that handles completely different thing. This is often a sign that you're breaking the single responsibility rule. This is very similar to tip number 3, but instead of checking the imports, check the props. So you need to also examine if your props are all over the place. So I call it the all over the place rule. Check that your imports are not all over the place. Check that your component props, in this case we're not getting props, so this is not a sign in this example, but check the props of your component. If the props are really non-related on different topics, it's often a sign that your component is breaking the single responsibility. The next tip number 4, is check how long your component is. Often if you have React component that is very long, it's often a sign that you're breaking the single responsibility. In our case, the bad component is pretty long. So we can see how when we will create the good to do, we'll see how short this component actually needs to be. But we see that the bad to do is actually pretty long. So it's a good sign that we're also breaking the single responsibility rule. Now another tip is check your ifs. So if you have a component and it has a lot of branching, a lot of if, and every if is rendering something else, it's often a sign that you're breaking in that component the single responsibility rule. And we actually have this in the bad to do. This is a really strong sign here because we have different case where the component renders a loading or renders an error or renders a to-do list. If you have those different ifs where your component has different cases where it renders every case it renders something else, this is actually another bad sign, another sign that you are breaking the single responsibility principle. The next tip is if you want to extract logic, often custom hooks will help you extract logic from a component. So in our case, the bad to do, we can extract the logic of sending a query to a custom hook. Let's do it in the good to do. Let's open the File Explorer and create a new file in the good to do folder that is called todo.hook.js, and in here we'll create a custom hook to grab the list of to-do. So we'll export a function called use to-dos. And what we'll do in this function, we'll go to the bad to-do and we'll copy the use query that we placed in the bad to-do, and we'll simply return the use query and extract it to a custom hook. Now think about the reusability here. You could actually use this query in other components as well. What we couldn't do in the bad to do, it was really coupled in that component, was really in that component. By doing a custom hook, you can extract the logic, remove one of the principles of the bad to do, remove one of the tasks that the bad to do is doing to a custom hook, and you can actually reuse that custom hook as well. So we created a use to do. Let's go to the good to do and let's import the custom hook that we just created, and we'll call this custom hook here, and now we can grab the to-dos and the error and is pending. So custom hook is a good way to extract the logic that often use other hooks, extract the logic from a component to some kind of util that can actually be reused, and thus you are removing one of the tasks of the bad to do. You're removing a task and moving it to a custom hook. Our next tip, Suspense, can actually help you extract the loading logic outside your component. So in the bad to do, we saw that we have here if is pending, then we will return a loading. Now often we actually want to share this loading state, and often we want to also share that this loading state is often we want to share this loading message, loading spinner, and often we want to share the logic as well. While a component is being sent, show this loading sign. So we want to share the logic and the actual UI. So what we can do, we can use Suspense. So in our to-do hook, we can, instead of using use query, by the way, I didn't import the use query, import use query from React query. So instead of using the use query, I can use the use Suspense query. So I can use this instead. Now if I'm using the use Suspense query, so let's place the good to do. I'll place in a good to do, I'll place an index file just to barrel out the good to do. So I'll export the good to do, and then in my app.js, instead of the bad to do, I'm going to import the good to do. Okay, so we're placing the good to do. Now the good to do is calling the use to do's hook, right? And the use to do hook is using the use Suspense query. This means that in the app.js, we have to wrap the good to do with a Suspense. So let's wrap with a Suspense. And while wrapping in a Suspense, I can put the loading UI inside the fallback. So I can put the div loading here, or I can create a component for the loading sign. So I can use it here, and this way I'm extracting the loading logic outside the good to do, and the Suspense is handling it. And the good to do is using the use to do, which is calling Suspense. This means that if you're using Suspense, you don't have the is pending, you're already getting the data. Also, you don't need the error because you actually use the suspense, the use suspense query is actually using error boundary. So it will help you extract the error. We'll see this tip in a minute. So we actually see the data and we're getting the data. The data is not undefined because we're using suspense here. The data will always be defined. So let's go back to the next tip. Our next tip is use error boundary to help extract and share the error logic. So in React, usually for error boundaries, there is a package. Let's see, error boundary. I think it's called React Error Boundary. So let's install this package. Oh, sorry. So I'll install this package. And what this package will give me, it will allow me to import a component from React Error Boundary, a component that is called Error Boundary. And I can wrap, similar like Suspense is wrapping and giving the fallback for loading, I can do a similar thing with Error Boundary. Also, I think it's fallback component. Is it fallback component? Let's see if it works. And we can wrap similar to Suspense with an error boundary. So, and let's see the documentation of error boundary. So error boundary, sorry, gets a fallback. So let's display a fallback. And there were and right in the fallback there was an error. So we're actually doing something similar to Suspense to extract the error logic. Now we don't need, in the bad to do, we don't have the if is pending and if error. We actually extracted it, shared the logic, and now it's shared among multiple components. So I can place additional components inside the Suspense and inside this error boundary. Sorry, the tabs seem to be inside this error boundary, and then they will share the same logic that sending a request will be pending, while the pending it will display loading, and if there is an error it will show this. So let's finish up our good to do component. So now we have the data, and the good to do is actually let's go to the bad to do and copy this. And we don't need the data, the question mark here. We always get the data because when there is no data, this component is not displayed. We have the Suspense fallback, which is displayed. Let's import the MUI items that we're using. And we actually successfully extracted the loading logic using Suspense, and we extracted the error logic using error boundary. So now our component is doing much less than the bad to do. We actually moved logic by custom hook, by Suspense, by error boundary, and actually focus on the single task that this component needs to do, which is to render the list. Our last tip is to split to smaller components. So let's go back to our good to do, and instead of doing a list and list item, let's split and create in the good to do item. Instead of implementing in the good to do, the to-do list and the to-do item, we'll focus on just the task of the good to do, a single principle, a single task to render the list of to-do item. So we will take the logic of the list item and create a component to-do item for it. So I'll export a function called to-do item, and this to-do item will return a list of to-do. Now it will need to get in the props that to do that it needs to display. So it will get in the props, it will get a to do item. Now let's import what we need from MUI. So let's go to the good to do and go grab all the list item that we're using. Great. And let's go to the good to do, and instead of placing the list items, let's place just the list. And let's import the component that we just created. Now, instead of placing the list item, I will simply place the to-do item. So the to-do item will get a key and will also get a to-do. Now let's see if our good to do is working. Look how short the good to do has become, focusing on only the list. So let's go and back to the app.js and see if our good to do is working. Let's go to the browser and we see that our good to do is working and displaying the to-do list. So check out how from a bad to do, doing a lot of different tasks, we actually moved to a good to do, focusing on just displaying the list. We extracted the sending a query to the server, we extracted the error in the loading, and we extracted the to-do item. We all separated from this component and made this component only focus on a single task, a single principle, displaying the list. Let's summarize what we learned in this lesson. We talked about S.O.L.I.D and the single responsibility principle and how that principle applies to React component. So we talked about that often we want our React components to solve a single task, a single problem. And we also, if you follow this principle, if you follow the best practice that we talked about in this lesson, it will help you organize your code. It will help you learn how to properly split your components and split your logic. It will make your code easier to test because every component, every item has a single task. It will make your code easier to scale. And we gave a few best practice tips. For example, write comments before you start writing will help you plan and will help you write down what single task should your component solve. We understood the signs where you're breaking the single responsibility principle. Signs like look at your imports, look at your props, look at your ifs in the component. Are you rendering different things in different cases? So notice those signs where you're breaking the single responsibility rules, and use the tools React is giving you to extract logic. Rather, if you want to focus on single task, you might want to extract logic out of the component. Extract logic by using custom hooks, by using Suspense, by using error boundary, by splitting to smaller components. So that's it. Thank you for listening. As a reminder, I'll place a link in the description. This entire lesson is available in our open source site, academies.com. Everything we teach here is completely open source, MIT licensed and free. So feel free to go to GitHub and star us. Feel free to also subscribe to our channel, like our content. And if you have other signs, other best practices you use to maintain the single responsibility principle, write down in the comments. We would be happy to hear about it. That's it. Thank you for listening.